Hey there. In the last video, we solved systems of equations by graphing. In this video, I'm going to show you how to do, we're going to solve algebraically, so we're going to solve using substitution and elimination. So to solve graphically, let's just do one of those real quickly here. Just to review that, we have to graph equation 1 and equation 2 on the same set of coordinate axes. So I'll do that now. Equation 1 is in standard or general form. So what I'm going to do to graph that is I'm going to find my x and my y intercepts. So I went over this in the last video, but to find your x-intercept, you're going to let y equal 0. And to find your y-intercept, we're going to let x equal 0. So whichever intercept we're finding, we let the other variable equal 0. And intercept means that's where it crosses the x-axis or the y-axis. So if I'm going to find my x-intercept here, I'm going to put y equals 0 into this top equation here, and I would get 3x minus 3. I'm putting in 0 because I want to find out what x is when y is 0, and that is 3x minus 0, so I don't need to write it, so 3x equals 9, and if we divide by 3, we get x equals 3. So we know that the point 3, 0 is on the graph. That is my x-intercept. It's where it crosses the x-axis. And then to find my y-intercept, I'm going to put 0 in for x. So I have, I'll go over here, 3 times 0, which that is just going to be 0. So you can write that if you want to, but 0 minus 3y is negative 3y. Don't forget that negative equals 9. And divide by negative 3 this time. And our y-intercept is negative 3. So when x is 0, y is negative 3. And so on the graph, it's down here. So we have 2 points. That's plenty to draw in the line. That's all you need is 2 points. So there's my first equation graphed, and then I'm going to graph the second equation on the same set of axes. This time we have it in slope-intercept form. Y equals mx plus b. In place of m, there is nothing there, so it's a 1, and in place of b, there's a negative 3 there. So our y-intercept is negative 3, and there we go, that's on that line, and a slope of 1, go up 1 and over 1, up 1 and over 1. This one's a little bit different than the ones we did before, because what do you notice? We're on the same line. So these two equations in different forms are actually the same line when we graph it. What that means is it was case 3 from the previous video. When we have the same line, you have an infinite number of solutions because every single pair that's on the blue line is also on the green line. And so we have an infinite number of solutions for this situation. So it's infinite solutions, same line. All right, and those lines are called coinciding lines. Let's do one more here. We can do this in either way. You can rewrite it in slope-intercept form. I'll do the top one. I'll do by finding x and y intercepts, because it's in that format. And so if I put 0 in for y here, I'm going to get x minus 0 equals negative 1, or x equals negative 1. So we know the point negative 1, 0 is on our graph. And then if I plug 0 in for y, for x I mean, here, I get 0 minus y equals negative 1, or I don't need to put the 0 there, so negative y equals negative 1, divide by a negative 1. This becomes positive y equals positive 1, because a negative divided by a negative is positive. So the point 0, 1 is on this graph. We have that those 2 points, and I'm going to draw that line in here. And let's see, there's my top line for equation 1. And the second graph, or the second equation, equation 2. This is pretty easy to also rewrite in slope-intercept form. Slope-intercept form has y on one side by itself, so I can simply subtract the x from both sides. X minus x is 0, so this is just y. And then I'm going to put the x term in the front. This negative sign goes with that x term because it's in front of the x, and then it's minus 3 here. So my slope is the number in front of x, which there isn't one, so it's a negative 1. Don't think that it's 0, because if it was 0, that whole term would drop out. And then where the b, the y-intercept is, we have a negative 3. So here we are at negative 3, and we have a slope of negative 1, down 1 over 1. And I can go up to the left, because going up is a positive, going left is a negative. Yeah, let's see here. And so this does not look like it's intersecting at an exact point, which is the whole reason that we want to also, well, not the whole reason, but it's one really good reason why we want to have an algebraic method to solve these types of problems. If they don't intersect at exactly an intersection point, like with whole numbers, then we have to estimate. It looks like about negative 3. And maybe it's just my graphing. Maybe it is, let me think here for a second. This would be a slope of positive 1. So if I follow that backwards, let me see if it gets to an intersection point. It'd be here and here. Yeah, it's somewhere in between. We don't really know what the y-coordinate is. It looks like the x-coordinate is about negative 3, and then the y would be, I don't know. Hold on. Okay, so I figured out what I did wrong. I solved it algebraically to do that. If you notice, you probably noticed this when I was graphing it, this y-intercept is at negative 3, and I put it down here at negative 4. So my line is off. It's actually right there. And I found the solution algebraically and realized my mistake by doing that. So this solution right here is actually negative 2, negative 1, and you can check it in both equations and it'll be true. If you put in negative 2 here for x minus a negative 1, you add 1 and you get negative 1. And then negative 2 minus plus a negative 1 is negative 3. So it works. Okay, so let's go through this, the algebraic method. Method 1 we're going to look at is called the substitution method. So the substitution method you're going to want to use when you have one equation solved for one of the variables. So if equation 1, x plus y equals negative 27, and equation 2, y equals 5x minus 3. This second equation is solved for y. Y is on one side by itself. And so if y is equal to 5x minus 3, they're equivalent to each other. Y and 5x minus 3 are equal. That means I can substitute in 5x minus 3 in place of the y up here in equation 1. So this is the substitution method, because I'm substituting in this expression in for y. And the reason you want to do that is you cannot solve an equation that has two variables and two unknowns. So we need it, and when we do the substitution, you'll see instead of an x and a y in this equation, I'm replacing the y with 5x minus 3. Now that equation is all in terms of x, and I'll be able to solve for x. And then I'm going to keep going here, equals negative 27. Combine your like terms. That's a 1x plus a 5x. Those two combine to become 6x minus 3 equals negative 27. And we're just going to go about the process of solving for x. So I'm going to add 3. Be really careful. What is negative 27 plus 3? So you're down to the left of 0 on a number line at negative 27. You're coming back 3 units. So it'd be negative 24, a little bit less negative. And then divide by 6, and we get x is equal to negative 24 divided by positive 6 is negative 4. All right, put that in a little box so you don't forget what that x value equals. And then the next step that we're going to do is we've solved for x. Now we're going to solve for y. To do that, you pick either one of the equations. I'm going to pick equation 2 because this is already solved for y. So I'm just going to put in negative 4 for that x right there. And then I can get the value of y. So y is equal to 5 times negative 4 minus 3. So I get y equals negative 20. 5 times negative 4 is negative 20 minus 3, which is negative 23. So now let's check that answer in equation 1. Equation 1 is x plus y equals negative 27. And I should have done this. We found out that y is equal to negative 23. So remember that, like when we were doing it on a graph, we were finding where they intersect. So they intersect at the ordered pair negative 4, negative 23. But I'm going to double check to make sure that that is correct. That's an xy ordered pair. Make sure you put x first and then y. So equation number 1 is x plus y. Does that equal negative 27? So x is negative 4 plus negative 23. Does that equal negative 27? You add two negatives together, you get a bigger negative. That's negative 27 equals negative 27. And so it checks out. And then you can check it in equation 1 as well. That should work because that's where we got this negative 23 from. In equation 1, does x plus y equal negative 20? Oh, equation 2, I mean. Does, if I put in negative 23 for y, so negative 23, does that equal 5 times negative 4 minus 3? We have negative 23 equals negative 20 minus 3, which it does check out. All right, so this is another problem here where you would maybe want to use substitution because x is solved for and on one side by itself. So I want you guys to try to do this. Pause the video, put in place of x, put negative y minus 5 in parentheses because it's 3 times all of the value of x and it's this whole thing. So put it in parentheses, distribute your 3, solve for y, put it back in your value of y to solve for x, and then come back and check your answer. All right, so the first step is to substitute in that negative y minus 5 in place of the x right here, since x is equal to that. Distribute the 3, so you get negative 3y minus 15, and then minus 4y equals 13. Combine your like terms here. You got a negative 3y minus 4y. That's a negative 7y. And then you still have this minus 15. Then continuing to solve for y, you're going to add 15 right here. And you get negative 7y equals positive 28. Divide by negative 7 on both sides here. And you get y equals negative 4. So we know our y value. The second step here would be to plug it back into one of the equations to solve for x. I picked equation 2, which will be the easier one because it's already solved for x. So when we throw in negative 1 for y, we have this negative, and then y is a negative 4 minus 5 from this part, and then for a negative, double negative like that makes that a positive 4 minus 5, which is equal to negative 1. And then you should check that in both equations to make sure that it's correct. So we can do that right here. I'm going to, so my solution was negative 1, negative 4, oops, didn't mean to almost erase that. I'm going to erase all of this so that I can check my work because it's actually really crowded here. Okay, so now we're going to check our answer. We're going to check this solution negative 1, negative 4 into both equation 1 and equation 2. So if I put negative 1 in for x minus 4 times negative 4, does that equal 13? So this is negative 3, and then I have a double negative. Negative 4 times negative 4 is plus 16. Negative 3 plus 16 does equal 13. And so that checks out, but let's check the second one. So we have negative 1, I'm putting in for x, equals negative, and y is negative 4, got that double negative again, minus 5. That's does this work, or does it equal each other? The opposite of negative 4, think of this as the opposite of negative 4, which is positive 4, minus 5, which does equal negative 1. So that checks. All right, so I will in the next video do another substitution and some elimination